Binomial distribution. Session prerequisites. Browse to our earlier material on uniform distribution, random sampling, Bernoulli trials. In preparation, please have the spreadsheet open on your computer and follow along. Maximum benefit guaranteed. Learning objectives. Generate the binomial distribution given the parameters: probability mass function, cumulative distribution function.
A binomial variable x is the sum of a fixed number n of Bernoulli trials with these conditions. The trials must be independent, the probability p remains constant across the trials, and we write x as binomial in n and p. Binomial variables are used to model situations involving sampling with replacement, like when we toss a coin and record the number of heads in a fixed number of tosses. We haven't eliminated any outcomes in the future. In reality, we sample without replacements. After we select the first manager into our sample, the pool of the managers goes down by 1. The probability of bringing the second manager into our sample changes, although marginally. We can relax the independence condition if our sample size is much smaller than that of the whole population. We can think of it as being less than 5%. We have a manager population of a little under 4,000, whereas our sample size is 200. That's less than 5%. Let's get back to our problem. Suppose we select a sample of size n is equal to 200 from this analysis sheet. Let x be the number of employees in the sample with college degrees. X can take the entire range of values from 0 to 200.
What's the underlying distribution of x?
She always asks this question. And it's a good one to ask as well. I'm not complaining. Let's illustrate this with a small sample of size n is equal to 10. Suppose 4 of the managers have a college degree in this sample. The probability of these 4 being in the sample would be the product of p repeated 4 times and 1 minus p repeated 6 times.
P is 48.2%, right? I'm so brainy.
Right. One more thing, these 4 can occupy any 4 positions within the 10 seats of the sample. So we have probability of x is equal to 4 is given by this expression where 10 choose 4 is 10 factorial divided by 10 minus 4 factorial times 4 factorial.
God help us if our sample size was something big.
Not to worry, Lisa. That's why God made spreadsheets with a function called binomdist. This takes in 3 parameters. Let's start with Lisa's suggestion to survey 200 managers. What we will do is calculate the PMF as well as the CDF by setting the last parameter of binomdist to 1. I'm going to start with Lisa's suggestion of upping the sample size to 200. This is the probability P of a manager having college education, that's 48.2%. Here is the probability mass function which gives us point probabilities, and here is the cumulative density function, and this column is very useful. It gives us the probability that the number of managers in the sample that have a college degree exceed the certain number that is there in column B. I'll now populate these columns. Before we proceed, let's figure out what the parameters of the distribution are. Our mean is around 96 and our standard deviation is around 7. We will ask you to show separately that the binomial distribution approaches a normal distribution for reasonably large values of n and p. So this being the case, I know that close to 95% of the data is between mean minus 2 sigma to mean plus 2 sigma. So what I'm going to do is to approximately start at mean minus 3 sigma and go all the way up to mean plus 3 sigma. The probability, the point probability of the binomial distribution for x is equal to 71, given that my total number of trials or size of the sample is given in this cell constantly, of course. And the success probability, or as in our case, managers with college education, is 0.482. I'm going to throw in a dollar sign one again. And 0 is our cumulative flag over here. It means give me point probabilities. I have a very slight probability here. I'm going to double click this and it populates everything. So this was our probability mass function. Now I would like to know what the cumulative density function is. So I'll go with binom dist x at the value 71, again constantly 200, and constantly the probability p, which is 0.482. This time the cumulative flag is 1. I will double click on the cursor and I've got this. Now the probability that x exceeds the value 71 is given by 1 minus the cumulative probability, which is pretty much close to 1, 99.98%. So we have indeed made a good choice of starting from 71. Let me go all the way down. And what's the probability that x exceeds that last value? 0.0003 or 0.03%. We can live with that. This is how the PMFs look for a fixed n is equal to 200 and different values of p. We must focus on the reds past the line at 100. We need to figure out what the probability of at least 100 managers with a college education is. And this is the cell we should be looking at. Alright? That's 0.33, meaning the probability of managers with college education exceeds 99, which means starts at 100 and goes over, is 1 in 3. That's theoretically speaking.